Yeah.
Yes, sir. Like in the one of the sums we covered before, in the one-way slab design, sir. Like we'll be taking the control of deflection condition, right? So is it L like in that L by D? Is it like total depth or effective depth for the D in that L by D thing? Sir, your voice is breaking. Sir.
Right, your line is a bit. You can use effective depth actually. See, there's nothing specified. In codebook, it does not specify whether it is overall depth or effective depth for one-way slab. So you can use
Okay.
for it. But two-way slabs, it's mentioned as overall depth.
Oh, okay, sir.
But one good thing is in slabs, for most of the practical loads which you get, when you design that slab, you will get a very low thickness for the slab. So just increase it based on say ratio of 20. Okay, approximately what you can do is if you're having a one-way slab which is simply supported, usually the percentage of reinforcement which you will calculate at the end, if you have done a proper design, the final PT which you get will be something like between 0.3 to 0.7 or something like that, the PT percentage. So for that PT percentage 0.3 to 0.7, you will usually be able to use a modification factor as 1.5. So what you can do is L by D. The ratio which you can use is you can be 20 into 1.5 or 26 into 1.5 like that. So you can just use that ratio and decide what should be the slab depth. Only thing is finally when you find the percentage of reinforcement, check whether it is like that 0.3 to 0.7 or something in that range. Okay, so instead of using 20 or 26, use 20 into 1.5 or 26 into 1.5 as the limit for one-way slabs and for all kinds of slabs in fact.
Okay, sir. So whether we take overall depth or effective depth, it doesn't really matter much.
Don't have a permission. If you take over effective depth, you are safe. That's all. No one. There's no other answer. You will be safe if you take effective depth. Overall depth, you will be economical. Okay, that's not a big issue.
Okay, sir. Thank you.
Okay. Finally, staircases. So I need to tell you what the types are and what are the loads. There's nothing else to show in this. Okay. So you will know what some definitions like landing and rise, tread, and things like that. You people have not had basic civil, so I don't know. But people who do basic civil, they'll have this parts of a staircase and those things. Okay. So anyway, so you're starting up. So this directions tell you what it is. So you're starting from here, going up. Okay. So you're having steps. Then there's a flat part. Okay. So whenever in the staircase you have a flat part, that is known as a landing. I think you people would know that. So depending on how the landing is, you have different things. So you have a straight staircase with no landing, also just direct bottom to top, that can be there. Or if it's a very tall staircase, if you don't give a landing in the middle, people will lose their breath. Okay. So you may have to give a landing whenever you have, for example, railway stations and all, when you cross the platforms in the staircase, it's not one staircase from the bottom to top. It will have a landing so that people can breathe. So L-step staircase means it goes up and then it turns. That is one type. Then we have double L going up, coming around. Okay, U-shaped. Okay, where the difference between double L and U-shaped staircase is in the location of the landing. Okay, so in a double L staircase, we have steps, then a small landing, and then going up again, then landing, and then coming down. In a U-shaped staircase, you have steps, and then the full landing, which is parallel to both the set of stairs. Then you have winder means it goes up, and whenever you turn, then it becomes the width is more on the edge and it's radial. But this is not too good. Many places, whenever you see this kind of staircases, people would have experienced. Some of you might have experienced as well. You may trip, you may sprain an ankle. Okay, no, all sorts of injuries are possible when this is especially when climbing down. You also have much worse 180 winder staircases. Curved staircases are there, spiral stairs are there. Okay, no, like in a lighthouse, your staircases will be spiraling up. Okay, so these are some different cases. So what to design in a staircase? Basically, you will have to design the slab on which you have made the stairs. You have to design the landing slab. And if the staircase slab is supported on beams, you have to design those beams. That's it. So depending on how the staircase is supported, you have two cases. So if this is the direction of your movement up, and the staircase is supported on the edges, this is one case. The other case is you start here and go up, and the staircase slab is supported on the bottom and top. So is it supported parallel to the direction of climbing, or it's supported on the two edges at the ends of the climbing direction? Okay. So these are basically these two cases decide what type of design you're going to do for a staircase slab. These are definitions. So this, if there is a beam which supports this is known as a stringer beam. This is raised, this is spread. Okay, usually you have an angle which you should use. Head-to means you should, if somebody climbs on the stair, he should be able to stand. He shouldn't be crouching and all. So how to take the effective span of this slab, of the staircase slab? So it's basically given by this. This is known as landing. The part where you climb is known as going. And again, so landing and going. These are the words. Going is subscripted by G. And say that I have, these are two cases where the support is here and here on the direction of climbing. This second case is the support for the staircases is, or the support for the landing rather is, it's in this phases. Okay, so both are different cases. So here the support to the the stair steps are parallel to the riser. Okay, riser is this. The waist slab bends along the direction of flight. So basically meaning that you're climbing up. Okay, so that is a load. Okay, the live load and dead load which comes on the top of the slab. The staircase slab is going to bend in that direction. So this is if it is simply supported. If it is, it could also be cantilevered where you have a wall or a beam on the edge, and the staircase slab may be cantilevered out of it, and on top of that you may have a staircase. So both are possible. So stair slabs may be cantilevered for the wall or beam, and or stair slabs may be supported between the stringer beams. Okay. So these are cases. And now how to find the effective span? Okay, so if you have a system like this, so this is the width of one landing, this is the width of the other landing, 2x and 2y are the widths of the landing. Going direction is G. Then the effective span should be this. If x and y are less than 1 meter, then it's G plus x plus y. And whenever x or y goes more than 1 meter, then that particular thing you can restrict it to 1 meter itself. So G plus 1 plus 1. So I mean, this table is understandable by just reading it. So according to our IS 456, not IS 456, IS 875. Okay, there's a code book known as IS 875. IS 875 is a code book. It has 5 parts, in fact. It has 5 parts, I suppose. Part 1 tells you how to calculate dead loads. Part 2 tells you how to calculate live loads. Part 3 tells you how to calculate wind loads. Part 4 is, I think, snow loads or something. Okay, so this, so any given type of building, so how to take the live load on a staircase, how to take live load on a beam, on a wall, column, whatever it is. So according to IS 875, this is the loads to be given on a staircase for a normal building. Okay, so 3 or 5 kN per meter square should be the live load, and if the staircase is cantilevered, then at the tip of the cantilever give 1.0 kN also. Okay, So say that based on this, you're able to find the load W. So if you look at this particular picture, you see that there's a going, there's a landing, a going, a landing again, and then a going. So there is, so this part of the staircase is, so this landing is common to both this direction and this direction going. Similarly, this landing is common to this direction going and this direction going. So whenever you have a landing which is common to two different directions of climbing, then what you should do is, when you consider this direction, take half of the load on this for this direction and half of that load for this direction. Okay, that's why it has become W by 2 over here. So the load on the area common to the two systems of flights or stairs is to be taken as half in each direction. Okay, that's why here you look, it's till here it is W, here it is W by 2. If you look at this direction, within this part it is W, and on this landing and this landing it is W by 2. So this is it. So this is the only thing that needs to be covered in staircases, nothing else. So otherwise, the design of a slab, of a staircase slab, is very similar to design of a one-way slab, as a design of a one-way slab, and you can, just depending on this difference, whether it is supported this way or whether it is supported this way, you will have some differences in the way of design. Okay. Otherwise, there is no big difference in it. Okay. I'll give you some example problems. Probably I'll just type it out and post it. So you'll be getting an assignment to do on a flat slabs and probably 2 problems on staircases now. Later, much later, after I complete everything, you will have 2 more problems, one on slender columns and one on footings. Okay, on combined footing. So 2 problems will come later. So this I'll just send it to you. I'll also send you the reading material to refer to it. So this PPT, 2 steps also over. So this PPT I will upload. Till the columns part, whatever I've completed, I'll upload this PPT. I'll also send you a sample of problem so that you can read it and then you can start solving it on your own. Okay, fine. So if any doubts are there, you can ask. Otherwise, we can meet tomorrow. Okay, fine. Then we'll meet tomorrow. I will just send you your photos of the problem. Okay, fine. See you then. Bye. I'll end the meeting.
Thank you, sir.
Okay, fine. Bye.
Thank you, sir.
Thank you, sir.